Welcome back today we're going to be doing LeetCode number 73, set matrix zeros. So basically we're given an m by n matrix where m is the number of rows and n is the number of columns. And this is an integer matrix where if an element in that matrix is 0, we want to set all the rows and columns that it belongs to 0. So in the first example, we see that this middle element is 0. So we set this entire row to being zeros, then the entire column to being zeros as well. Same thing with the second example, we see that this entire row should be zeros, which it is. And then these two columns, because the 0 belongs to those columns, should also be 0, as you can see. So let's get to the iPad and let's explain this out. All right, so let's get into the iPad explanation here. So again, like I said, this is the first example from LeetCode, and the second one is one of their internal examples. I have this one because it's going to help us like go through a use case that I'm going to talk about later. However, essentially the question is like, we have the zeros here, right? And essentially we mark all the rows and columns that these zeros belong to zeros. So all of these ones, all of this should be converted to 0, and all of this should also be converted to 0, and we see that in the answer, right? Same thing here. We can see that this column, or the first column has a 0, so this is going to be converted to all zeros. This column also has a 0, so all of those all those values in that column should also be converted to 0. And then the last one also has a 0 in it, so those columns values should also be converted to 0. Same thing with the rows. The second row should be converted to all zeros. Third row should be converted to zeros, and the fourth row should also be converted to zeros. So we see that in the answer, right? These are all zeros, and all these columns are also zeros. The 3 is the only one that is not converted to 0 because that column and row, it does not belong to a column and row that has zeros. So how do we go about doing this? Well, first thing is we need to come up with a brute force approach. So the brute force approach for this question is going to involve marking where zeros are occurring. So what I mean by that is we can essentially look at this in this way. So this is our given input, right, for the first example. What we can do is we can essentially keep two arrays. So one array will represent the columns, and then the other array will represent the rows, right? So rows and columns. And essentially what we'll do is like we'll iterate through the entire 2D vector or array and see where the 0 is. And these are all going to be initialized to 0 initially, right? And then we're going to see where the 0 values are. So wherever we find the 0 values, we're going to go to our column and our rows and mark that to be a 1. So this is going to be a 1, this is going to be a 1 because it lines up properly with where the 0 is. Then what we're going to do is we're going to iterate again through the 2D vector and check, hey, if we're ever at this column or this row, convert it to 0. So we're going to say, hey, I'm at the second column, so convert to 0. Then, hey, again, I'm at the second row, convert all of these to zeros, right? And then, hey, again, I'm at the second column again, convert it to 0. And you see that it gives us this answer. So this is going to work. However, the only thing with this is like time complexity is going to be O of m times n. And this is because the rows and columns are not guaranteed to be the same, so we have these two variables. But the disadvantage here is that our space complexity is going to be O of m plus n. And this is because we're using two external arrays or vectors to store these hashings, basically. It's basically a hashing concept. So we're using that external space here, right? But the best optimal approach actually can get us down to O of 1. This is our actual goal, right? This is what we want. So how do we do that? So the optimal approach actually will involve, essentially, the whole point is like we know that we want to reduce the space, right? So what if we just use the 2D array itself, right? What can we do with the 2D array using the hashing idea to make this work? So I'm going to use the second example here. So I believe this is like 1, 2, 3, 4, and this is 5, 6. That might be a 0. 5, 0, 7, 8. Then we have 0, 10, 11, 12, and then we have 13, 14, 15, and a 0. So this example, right, we know we see the output and we know what we want. Now the idea is we're not going to use that external rows and columns arrays, right? So how do we do this? Well, what if we use the first row as our hash for the columns, and then the first column as our hash for the rows? So I'm going to draw out a figure here that is going to detail this, what I mean by this. Basically, what I'm saying is like, let's say this is our 2D array. We're going to say that this, which is essentially the zeroth column or the first column, whatever you want to think of it. I'm saying zeroth because of the indices. this is going to be a row hash. So this is going to basically indicate if any of those elements in that row or in that column, if any of those are zeros, then it's going to tell when we iterate through it, we're going to know that, hey, that row is always going to be zeros. Okay, and then this is going to be our column hash. This is going to be our column hash. Now you might be thinking, hey, why didn't you go through this, right? Well, the thing is, like, this spot is going to be the unique part, and this is the key of this. This spot is going to overlap, right, with the row and column if we were to include it. However, we can't, because one time our rows, that first row could be a zero, but that could affect a column later on, and that's not what we want, right? And so we basically, how do we take care of this? Well, I'm going to draw another box on top. This is going to be, hey, if the first column has a zero, then you want to make the entire column zero. So this is going to be stored in a variable, and we can call this a column marker, okay? And then this internal stuff is just inner data, and this is actually what we're going to change. So let's like run through this. So what I'm saying is, here we're going to go through the entire 2D vector, and we're going to check where the zeros are. So first we're going to come to this zero, and we're going to say, hey, this mark the row where this zero is, mark that first element of that row to be a zero, so this is going to be a zero, and then mark the first element of that column to be a zero, so this is also a zero, right? And this remains a zero, this becomes a 3, 4, 7, 8. It just stays normally how it would be. This is already a zero, but this is the first element of the row, so we're good. Now this is in the first column, so we can't change this one to a zero, that won't work. We need to change our column marker to be a 1. Our column marker initialized to a 0, we can change it to 1. Essentially, this is just like how we did here with the hashing. Like, it just tells us, hey, this column needs to be changed to zeros. So that's going to be changed to a 0, and this still remains the same. Remember, we don't change any of these on the fly because we don't know if we can do that yet, right? Then here, we're going to get to this 0, and we're going to say, hey, change the column, this first element of this column to a 0, so that's that one, and then the first element of the row to a 0. So the 13 is now a 0, then you have 14, 15, and 0. Right? We have this now. These are our mappings, essentially. So now what we're going to do is, essentially, we're going to go through the inner data now, right? Because we can't really deal with the row and column yet. We want to fix all the inner stuff first, because that's the easiest one to do. We can be for sure on those, right? So we go through the inner stuff, and we change it to zeros. Wherever we check, we go to the element, we check, hey, is your first element of your row or the first element of your column a 0? If so, change to a 0. So that's why here the first row and the first column will stay the same, right? Now the inner 0 is already a 0, so we're good. 7, yeah, my first element of the row is a 0, so that's a 0. Same thing with the 8, the column and the row, first element are 0. Same thing, you'll see that all of these will also be converted to zeros, right? Now we have to deal with the rows, right? Since we essentially are using the first column as our row hash, we want to do the rows first. So we'll check, hey, is this element a 0? Well, it's not, right? So it's not a 0, so we don't need to worry about changing this entire row to zeros. Then we're going to check, is my column marker is a 1? It is, right? My column marker is equal to 1. And since it is, we're going to essentially convert all the elements in the first column to 0. So that's why these all will become 0, and that's why we have our answer. Now you might be thinking, hey, can I flip-flop that? Can I do the column marker first? Well, if you did the column marker first, right, then yeah, this will all become to 0, and then you do the rows, then this would also become to 0. Well, that's not what we want, and that's the reason we can't do the column marker first, because if we did the column marker first, it's essentially changing our row hash, right? We're changing this entire column, which is our row hash. So we can't do that. We have to go with the rows first, and then we can do the column, because that's like the last part, right? So that's why our answer becomes this, and that's our final answer. And our time complexity, again, stays the same, right? We have to go through the 2D array. So this is always going to be m times n. That's fine. But now our space complexity becomes an O of 1, which is what we wanted. This is the best space complexity possible and the most optimal solution. So let's get into the code, and let's make sure we understand this properly. All right, so let's get into the code. So the first things first, I'm going to initialize m and n, basically the row and column values, so we don't have to keep calling the matrix size a lot of times, right? So matrix at 0 dot size. So that initializes the rows and columns. Then we want to initialize that column marker variable that we talked about to 0. First things first, we want to go through the entire vector, 2D vector, right? And we want to make our markings, our basic hashings based on the first columns and first row. So remember that the first column is the row hashing, and the first row, excluding the first element, is our column hashing because we don't want that overlap. So essentially, we're going to go through all of the elements here. So just a double for loop, like you usually would for any kind of 2D array. And we're going to go through it and we're going to check, hey, is my current element a 0, right? That current location row column is a 0, well, we need to make our proper hashing. So what we can do is, like, since we know that the first column is always the row hashing and there's, like, we're not worried about the column marker, this can automatically be initialized to 0. So this basically tells us whatever row we're on, the first element, right? That's always going to be a 0. And that's what the left side is going to be, right? Now, what we're going to do is we're going to check, hey, is my current column not 0? So it's like we don't have to change the column marker here. We just need to change the top row values, right? So that case, basically this is the first row, right? And then any column, that will be converted to 0. Else, this is actually part of the first column. In that case, we can't do it because we don't want the overlap with the first element in the row hashing, right? So we're going to change that to a 1. Column marker is going to be changed to 1. It was originally 0. So essentially that double for loop just did our hashing. Now we want to deal with the inner data that we talked about in the iPad, right? And inner data, remember, it's going to exclude the first row and the first column. So it has to start from 1, 1, right? And if it turns out to be that, we don't have enough elements, well, then this for loop is just not going to run. And that's good with us, right? We're not going to run into any kind of like index out of bounds problems. So essentially double for loop again, and we're going to check this time. So what the hashing enables us to do is, like, it's a marker, right? So we can check, hey, for my current row or column, is the first element 0 in that row, right? If that is, then we want to change it to a 0. So we do that. So essentially, is the first element, or based on the row, is the first element a 0, or based on the column, the first basically row, and then whatever column, that's a 0. That's where we did our markings. If any of those are zeros, then yeah, we're good. We can just change them to 0. And that does all the inner data, right? We convert all of them to zeros. Now we deal with essentially dealing with the first row, right? If the first element is a 0, then we need to make the first entire row all zeros, right? So check if the first element is a 0. And then if it is, we need to initialize our columns. Column's going to be less than n, right? And then column plus plus. And we're essentially going to change all the first column, or the entire first row to zeros. Remember, we don't do the column marker first because that essentially changes our row hashings. If that changes, then we don't know if this is actually correct, and it could make more of the elements 0 than it needs to, right? After we do that first row, then we're going to check the column marker. So we're going to check, hey, is the column marker a 1? If that is the case, then hey, we need to change everything in the first column to a 0. So same thing, same structure as the row that we changed above, except we just deal with the rows. So here, row plus plus, and then matrix row, and this is the first column, right? So we change that to 0. So let's run this, make sure we don't have any compilation errors or like anything that we misspelled. So you can see we passed those 3 cases. Let's just go ahead and submit it. We should pass all the LeetCode test cases, as you see we do. But yeah, let me know down in the comment section below. Like if you had any questions or any confusions about the explanation, I can answer your comments. And let me know in the comment section down below if you want to see any other kind of videos. But yeah, make sure to like this video, subscribe to the channel, and I hope to see you on the next one.